Antidifferentiation, also known as integration. This is the opposite of differentiation. So with the derivative, we went one way. With the antiderivative, we go the opposite way. So back to it. Now, there's a couple of different things that we can write it. So this was the derivative, f dash. Then the integral of f of x equals f of x plus c. So this is integration. Now there's a couple of ones that are standard, which we've just written here in the table. So be aware of those. I won't go through all of them. You can sort of go through that yourself. But this is the standard one, just with a normal x to the power of n. But remember, we're not differentiating with antiderivative. So when we, instead of taking away one, we're adding one. And we've still got the plus c. And then we've got all the others. This, of course, if we have a fraction, and we bring it up to the numerator, and it's x to the power of -1. And you've got your e, your sine, and your cos. And later on I'll show you the tan. If we want to find the integral between 2 points, we will integrate this first, and you get your f of x, and then we substitute the top one, and then we take away substituting the second one. So it's f of b minus f of a. It's like finding the area under a curve between 2 points. Example 1 says find an antiderivative for each of the following. Now, you can't see the rule, but I know what it is. But the integral of sine, it's a bad integral, ax plus b dx equals -1 on a cos. And remember, when we differentiated sine, we got cos. This time when we go the opposite way, we get negative ax plus b, and we have to always put a plus c. So here, the integral of sine 3x minus pi on 4 dx equals -1 on 3 cos 3x minus pi on 4 plus c. b, e to the 3x minus 4. Now the integral of this one here, I'll just write it over here, is 1 over a e to the ax plus b, and I've still got my plus c. So the integral of e to the 3x plus 4 dx equals 1 on 3 e to the 3x plus 4, and then I have my plus c. Part c, this is just a normal one. We're going to find the integral of 6x cubed minus 2x to the -2 dx. Doing the first one, x to the power of 4, 6 divided by 4 becomes 3 on 2, minus 2, add 1 to the power, gives me -1, divide this 2 by -1, so this gives me plus, and then I've got my plus c, which means it's 3 on 2x to the 4 plus 2 over x plus c. Example 2. Evaluate each of the following integrals. Now this time we're going to integrate antidifferent derivative and then substitute pi on 2 and then 0. So the integral of cos 3x, integrating the 3x, we get 1 on 3. Differentiating sine, we get cos. Integrating cos, we get sine of 3x. Now I'm not going to have the plus c. Now normally to show this, we put it in brackets like this. You can take out the third because that's just a power. So there it is there, just multiplying. Now we're going to put the pi and 2 in here, so we get sine of 3 pi on 2 minus sine 3 times 0 is 0. So I get the third. Sine of 3 pi and 2 is -1, so this is -1 minus 0. So this just becomes -1/3. Part B, that was part A there. E to the 2x, so if I integrate e to the 2x, I'm not going to write that whole thing again. I'm going to get 1 over 2 e to the 2x, and integrating e to the x, I'm still going to get e to the x. Some people just do it like this instead of the squared bracket like this between 1 and 0, so just be aware of that. E, substituting the 1 in, e to the 2 times 1 is 2, so we get a half. E to the 2 minus e to the 1. And I'm going to put this in brackets because I've got to take away this whole thing when I substitute the 0 in. So a half e to the 0 is 1, so times that by 1, minus e to the 0 is 1. So I get a half e squared minus e to the 1, and that's there. A half times 1 is 1. Sorry, is a half. Take away 1 is negative a half, but then there's this one here, so it becomes positive half. So I end up getting that one there. Part C. Now, sec squared. Now, don't forget that when we did, and I'll write it up here, we had f of x equals tan of ax plus b, and we differentiated this, we end up getting a sec squared of ax plus b. Now we want to go the opposite way. So when we integrate sec squared of 2x, we're actually going to get the half, and we're going to get tan of the 2x, and that's between 0 and pi on 8. So substituting that in, I'll take the half out as a factor, and I'll have tan. 2 times pi on 8 will be pi on 4. And 2 times 0 is 0, so tan of 0. Tan of 0 is 0, tan of pi on 4 is 1, so I've got a half times 1, which ends up being a half. That's part C. Part D, this becomes, I better write 0 to 1, 2x plus 1 to the power of a half dx. So this will become 1 divided by, using the rule, differentiate internally, is that. Add 1 to the power is a half plus 1 is 3 on 2, so times this by 3 on 2, of 2x plus 1 to the 3 on 2, between 0 and 1. So this time I'm writing it the other way. These cancel anyway. So I've got my third. So 2 times 1 is 2 plus 1 is 3, so 3 to the 3 on 2. 2 times 1 is 2 times 0 is 0, plus 1 is 1 to the 3 on 2, which is just going to be 1. So I've got a third, and this becomes 3 the square root of 3 minus 1. Now, if we're integrating 1 divided by x plus b, then we get this rule over here. So be aware of that. Example 3, find an antiderivative of that. So part A, the antiderivative of 1 divided by 4x plus 2 dx, using the rule, will become 1 divided by 4 log e, 4x plus 2 plus c. I'll just wait for that printer. Okay, part C. Now this time, part C value, part B. Forgot about part B. Evaluate 0 to 1. 1 divided by 4x plus 2 dx. Well, we've already found the integral in part A, so that's a quarter log e mod 4x plus 2 plus c between 0 and 1. And I'm going to do this and then get rid of the 4. I'll do it like that. It's easier to see. So substituting that one in, 1, I've got 4 times 1 is 4 plus 2 is 6, so we get a quarter log e of 6. And time putting the 0 in, 4 times 0 is 0 plus 2 minus log e of 2. Don't need the plus c. So log e of 6 minus log e of 2 is log e of 4. So I get 6 divided by 2 is 3, so I get a quarter log e of 6 divided by 2, which means it's a quarter log e of 3. See if I can squash this one in here, part C. So I already know that the antiderivative is a quarter log e 4x plus 2 between -2 and -1. This is mod in there, which means I want positive all the time. So I get the quarter in there. -1 being -4 plus 2 is -4. So I have log e of -4 plus 2 is -2. Log e of 2 minus, that will be -8 plus 2 is -6. Log e of 6, which is, that's going to be a quarter log e of 1 over 3. And if I want to make this as a positive instead of a third, I can bring the 3 up and it comes 3 to the -1 and 10 take out the negative, so I become negative a quarter log e of 3. Graphs of functions and their antiderivatives. In each of the following examples, we have to remember that the functions f and f are such that f dash of x equals f of x. That is, the function f is an antiderivative of f. So the antiderivative of an example 4, consider the graph solved for y equals f of x and y equals f of x. Shown, find f of x, so that's f of x. To show this, just a straight line, part A, so it's really y equals mx. There's no c, goes through 0. So I substitute 1 and 1 in there, sub 1 comma 1, I get 1 equals m times 1, so m equals 1, so I get y equals x. So that's all that one is, or in this case f of x. That's just a straight line like that. Part B, f of x. Now f of x, remember from the previous law, is the integral of this one. So f of x equals the integral of f of little x, which means it's the integral of x. I'm going to put my dx there, which means it's the x squared over 2 plus c. We also know that it goes through 0 and 1. So when you've got 0 or 1, f of 0 equals 1. So we get 1 equals c. Therefore, f of x equals x squared over 2 plus 1. So I found that rule. Here's another one that says the graph of y equals f of x is as shown. So this is a parabola. Sketch the graph of y equals capital F of x, given that f of 0 equals 0. Now because this is a parabola and this is the derivative, that means the antiderivative, so this is an x squared, the antiderivative must have been an x cubed, so a cubic. Okay, just to keep that in our mind, we know that this is all positive because it's the derivative, it's above the x-axis, so positive gradient. And we know that it's 0 there at that gradient. So really, if I was to sketch this, I would say very quickly y and x. It goes through 0, 0, because it tells us that. It goes through there. At x equals -1, it has a positive gradient. And then after the 0, it's got a positive gradient. So it's positive, positive, positive until -1. Then it's point of inflection because it's a cubic, and then back to positive. So really, something about here, this is going to go like this. Okay, something like that. Example 6. Now this one is positive above here. It's equal to 0 there, and it's a negative below, so the x-axis. And then we know f of 1 equals 1. Okay, so that's important. So really, we could have a parabola here. So I'm going to quickly try and sketch this. A parabola which has at x equals 2. Right, it changes. And we also know that f of 1 equals 1. So f equals 2, 2, 0. We don't know what the y part is. That's going like that. F of 1 is 1. I'm going to sort of put that up here. f of 1 is 1. So we've got our graph that comes down here. 1 equals 1 because they give us that. 2, 0 is the other one, and then it comes back up. Negative this part up to there, 0 there, and then back up. So that's that type of graph.